Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of parametric equations of a plane. So as per a problem, a plane has x equals 2m, y equals negative 3m plus 5n, z equals negative 1 minus 3m minus 2n, and m and n are parameters and there can be any real number as its parametric equations. So let's start with part A. By inspection, identify the coordinates of a point that is on this plane. We are given the parametric equations for a plane and we have to identify a point that lies on this plane. So let's start by writing the given equations. The coordinates of a point on this plane are the number terms in these parametric equations. In the x equation, there is no given number term. That means the number term in the x equation is 0. So the x coordinate of the point is 0. In the y equation, there is no number term. That means the y coordinate of the point is 0. And in the z equation, the number term is negative 1. So the z coordinate of the point is negative 1. So this is a point that lies on this plane. So this should be the final answer for part A. Now we can analyze part B. What are the direction vectors for this plane? So as you may know, a plane has two direction vectors which are non-collinear vectors, and in the parametric equations, the components of the vectors are the coefficients of the parameter terms. Now these equations have two parameters m and n. So one of the direction vectors has the components that are the coefficients of the m terms. The coefficients of m terms in these equations are 2, negative 3 and negative 3. So the first direction vector A is equal to 2, negative 3, negative 3. Now we can find the other direction vector from the n terms, the other parameter in the equation. The components of the other direction vector are the coefficients of the n terms in these parametric equations. So let's assume B is the other direction vector. So the x component of the B vector is 0 because the x equation has no n term. So the coefficient of the n term in the x equation is 0. In the y equation, the coefficient of the n term is 5. So the y component of the other direction vector is 5. And in the z equation, the coefficient of n term is negative 2. So the z component of the other direction vector is negative 2. So these are the two direction vectors for this plane. Now we can answer part C. What point corresponds to the parameter values m equals negative 1 and n equals negative 4? So we have to sub in these m and n values in the given parametric equations to find the coordinates of the point that corresponds to these parameter values. So let's start with the x equation. The x equation has only the m term, so we'll sub in m as negative 1. I get x equals negative 2. Now we can find the y coordinate of the point, and for that we'll sub in m as negative 1 and n as negative 4 in the y equation. I get y equals negative 17. Now we can find the z coordinate of the point, and for that we'll sub in m and n values in the z equation. I get z equals 10. So the point that corresponds to m equals negative 1 and n equals negative 4 is negative 2, negative 17, and 10. So this should be the final answer for part C. Now we can analyze part D. What are the parametric values corresponding to the point A, 0, 15, negative 7? So we have to find the m and the n values for the given point A. So we have to sub in the x, y, and z coordinates of this point into the x, y, and z equations and solve for m and n. So let's start with the x equation. The x coordinate of the given point A is 0. So we should sub in x as 0 and solve for m. So I get m equals 0. Now we can use the y equation and we'll sub in y as 15. We know that m is equal to 0. I get n equals 3. Now we can check whether the z coordinate satisfies the z equation for m equals 0 and n equals 3. So we sub in z as negative 7. So negative 7 is equal to negative 7. Therefore, we can conclude that the parametric values that correspond to the point A are m equals 0 and n equals 3. So this should be the final answer for part D. Now we can answer part E. Using your answer for part D, explain why the point B 0, 15, negative 8 cannot be on this plane. In point B, the x and y coordinates are the same as the x and y coordinates in point A. And as you can see in part D, from our analysis for the x and y coordinates, we got m equals 0 and n equals 3. If we sub in z as negative 8 in the z equation and m as 0 and n as 3, the values we got from the x and y coordinates 0 and 15, the equation is not true because we get negative 8 on the left side and negative 7 on the right side. So we can see that the left side is not equal to the right side. So that means that the point B cannot be on this plane. So this is a very important concept we need to understand and memorize. So whenever we have to check whether a point lies on a plane, the calculated values for the parameters should satisfy all three equations for the given point. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.